GeopByte.
Dear students, now let us discuss the previous year questions for the very important and easy unit, that is motion in two dimension is also called motion in a plane. Okay. Now from this very easy unit, the weightage for the NEET, minimum one question can be expected, maximum two questions can be expected for NEET. Okay. I hope all of you clearly understood all the theory concepts what we discussed for motion in two dimension. Understood or not? Yes. Then let us take the very first question. Look at the very first question asking like this. A particle moving with uniform speed in a circular path maintains. A particle is moving in a circular path with uniform speed. Options: constant acceleration, constant velocity but varying acceleration. Option C, varying velocity and varying acceleration. Option D, constant velocity. Dear friends, remember, by the time the particle is moving with uniform speed in a circular path, because of the change in direction of velocity and acceleration, both velocity and acceleration continuously changing. That means varying velocity and acceleration because of the continuous change in direction of motion. Understood clearly? Therefore, option C is absolutely correct. Then let us take the next question. Look at this question. It is asking like this. A bob is whirled in a horizontal plane by means of a string with an initial speed omega rpm. Omega equal to initial angular speed. Angular speed, it is given revolutions per minute. Okay. The tension in the string is T. T be the initial tension. Initial tension, that means initial tension developed in the string while it is maintaining the angular speed omega. The speed becomes two times the omega while keeping the same radius. Let r be the radius of the string. Radius of the string, it remains constant, given clearly. It remains constant, but angular speed, let it be omega dash, equal to 2 times the initial velocity. Then the tension in the string becomes, what is the new tension in the string? While the angular speed is becoming double. Okay. For that, look at the bob which is maintaining the uh, right motion, circular motion in a horizontal plane. This is the string, that is the string, and this is the what bob. Then the mass of the bob is given, let it be m. Radius of the circular motion, here radius of the circular motion is r, that remains constant. Then initial initial tension in the string equal to m into r into omega square. Okay, where m be the mass of the bulb, r equal to radius of rotation, omega equal to angular speed. Let that initial string tension is T, m r omega square. Final tension in the string, final tension in the string, final tension in the string, let it be T dash, equal to m remains same, r remains same, omega becomes omega dash whole square. What is the omega dash? Equal to 2 times the omega. It is equal to mr mr omega dash equal to 2 times the omega whole square. It is equal to mr omega square into 4. It is 4 times the mr omega square. It is equal to 4 times the mr omega square equal to t. So therefore, the tension becomes 4 times the initial tension. That is the answer. Okay. Look at the options. Look at the option A. Option A is absolutely correct. Are you following clearly? It is very simple problem. Okay. Similarly, let us take the another important problem. Look at this problem. Asking like this. A ball is projected from a point A. Look at the point A with velocity 20 meter per second at an angle 60 degrees to the horizontal direction. Look at the direction of velocity at an angle 60 degrees to the horizontal with a velocity 20 meter per second. At the highest point, that is B, of the path, on the path, as shown in figure, the velocity V meter per second will be, since the body or ball is projecting with a velocity v, that is 20 meter per second at an angle 60 degrees, then it is developing two component of velocities. Look at the two component of velocities. This is the horizontal component of velocity v cos 60, and this is the vertical component of velocity v sin 60. Dear friends, remember that horizontal component of velocity remains constant throughout the projectile motion. That means at the topmost point also, it is maintaining the same horizontal component of velocity v cos 60, but at the point B, vertical component of velocity vy equal to 0. So initial velocity v is given 20, cos 60 cos 60 equal to 1 by 2. It is equal to 20 multiplied by 1 by 2. It is equal to 10 meter per second. That is the horizontal component of velocity that remains same throughout the projectile motion. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A particle is executing uniform circular motion with a velocity v and acceleration a. Which of the following is true? Almost a similar problem we have discussed. It is given that a particle is executing in the circular motion with uniform velocity. Though the velocity is uniform, continuously direction of both velocity and acceleration both are changing. Therefore, v is not constant and a is also not constant. Option D is absolutely correct. Okay, na?
GeopByte.